starting a new topic. It's called differential equations. It involves still taking the antiderivative, but there's an extra part of it, and in some cases we can find C. So you start off with a problem where you know dy dx. And it gives you some other information like y of 0 equals 2, which is telling you that there is a point on this original equation at 0, 2. So what you do is basically you cross multiply, put that over 1. You would have dy equals x squared dx. You take the antiderivative on both sides so that you can solve for y. The antiderivative of dy is y. The antiderivative of x squared is x to the third over 3. And technically both sides have a plus c, but they could be different plus c's. If you just move them together, it's okay to just put a plus c on one side. And what that does is that gives us the original equation. But by knowing that this also goes through that original equation, I can plug that in for x and y to solve. So I'm going to plug the 2 in for y, I'm going to plug the 0 in for x, and then I find out that c is 2. So my final equation is y equals x to the third over 3 plus 2. So it's kind of the same as what we've been doing, except that you can solve for c if they give you some other information. Here's another example. So they give you dy dx, and then they tell you y equals 3 and x equals 1. If they didn't tell you the x and the y, then you would just solve both sides and end up with a plus c. But since they do give us the y and the x, we're going to find c. So the first thing is you want to get the y's together and the x's together. So if you multiply by dx, you would get dy equals all of this with the dx on it, which at this point is not a huge deal, but it will be on the next few problems that we look at. So then take the antiderivative on both sides, the integral on both sides. So you get y equals, the antiderivative of negative x to 1 over x squared. That's negative x to the negative 2. So if I add 1, I get x to the negative 1. Negative 3x to the 4th. Add 1, so I would get x to the negative 3. And then plus 12x, and then plus c. At that point, we're going to plug in the 3 and the 1. So that's 1 plus 12. Subtract 14. So your final equation is y equals x to the negative 1 plus x to the negative 3 plus 12x minus 11. All right. Here's a problem for you to try. On this one, you'll have to think about use substitution when you solve it, and then you'll get find the plus c by using the pi for x and the 3 for y. Now, on some problems, you might have it written differently. For example, let's say that you have this problem. Sorry, this would actually be number 3, I think. This one is different from the ones we've done so far because there's y's and x's on both sides. So this is the time where it really, really matters about trying to get the y's together and the x's together. So since these are just two equations, what I would suggest first is that you cross multiply. As long as you have the y's on one side, the y and the dy, and the x's on one side, then you're good. So you're going to take the antiderivative on both sides. The antiderivative of y is y squared over 2. The antiderivative of negative x is negative x squared over 2. Don't forget your plus c. Now, before you just start plugging in numbers, you should solve for y, because your equation should say y equals whatever. So I'm going to multiply both sides by 2. And be careful. If you're going to multiply by 2, you can't just multiply the first one by 2. It's multiplying everything by 2. And then you're going to take the square root. If you want to multiply by 2, that's fine, or if you want to leave it. Technically, we have a plus or minus here. So now I've solved for y. I have an equation in terms of y. And then I'm going to use this 0, 1 for x and y. So 1 equals plus or minus square root 2 times 0 over 2 plus c. Now, since I have a positive 1 over here, that means that we're really talking about the positive square root. So really, we don't want the negative square root. So to solve it, we square both sides to get rid of the square root. So 1 equals 2 times c, because that's a 0 plus c. Divide by 2, so c is a half. So that means that y equals, remember, the positive square root of 2 times negative x squared over 2 plus a half. So it's different because we have y's and x's on this problem. Okay. Alright, so we want to get our y's together and we want to get our x's together. And if there's extra numbers, we want to leave them with the x's. So this k here is just the extra number. We're going to leave it with the x's, but the y is what I really want to move over. So first thing, I'm going to put it over 1 and then cross multiply. So I get dy equals ky dx. So the part I really need to get rid of is that y. So I want to divide both sides by y. And then I want to take the antiderivative. Well, the antiderivative of something over y, since it's just a y, is natural log of y. And then the antiderivative of k, since we're doing it in terms of x, is kx plus c. Now, we want to solve for y. Remember, there's an understood e there, so I'm going to rewrite it in exponential form. Y equals e to that power. Now, there's an understood rule on these problems that we want to write this a different way. This is the same as writing it as y equals e to the kx and y equals c, because you can add exponents. So this thing, e to the kx plus c, is the same as e to the kx times e to the c. I know this is going to be kind of strange, but this is how it works. E to the c is just a number. So we're going to call it another number, maybe b, and we're going to put it at the front. And so this is the equation that we have. Y equals b e to the kx. And you're going to do that every time. Anytime you have a power of e, you're going to create this new b. We can call it c, but sometimes it gets confusing because b and c are actually different. Now, if I plug in the 2 and the 4, we're actually not going to be able to solve it very well. I want to solve for b because that's the thing I'm looking for. I'm just going to have to leave it as 4e to the 2k. So that means y is going to equal 4 over e to the 2k times e to the kx. And it's not a pretty equation, but that's the equation of that formula. Alright, here's another one. This one was similar to number 3. We're going to cross multiply. Notice our y's and our x's are not on the same side. So I want to divide by x on both sides, but I also want to divide by y on both sides. So I end up with dy over y equals dx over x. Then I take the antiderivative. The antiderivative of dy over y is natural log of y. The antiderivative of dx over x is natural log of x. Don't forget your plus c on the x side. And now I want to solve for y. Remember you understood e, so y equals e to that power. Uh-oh, I see that c in the power. We're going to do like we did on the last problem, and we've got e to the ln of x. E to the c is just going to be a number, so we're going to put a b in front. Another tricky thing, e to the natural log of x is understood to be x. That's just something that is a rule. E to the natural log of something is the something. So then we plug our 5 and our 3 in, and we get b equals 5/3. So our equation is y equals 5/3 x. Alright, since this is dh dt, whatever's on top represents the y. So the 30 is like the h, and the t is the 0. Again, we want the h's together and the t's together. There's no t's here, but there is an extra number. And if I could get that number with the t's, then that would be good. So if I like cross multiply, think of it as being over 1 and cross multiply. I get that. But really then, I just want to divide by that h of 20, or h minus 20. Now I want to take the antiderivative on both sides. Now on the dh over h minus 20, you can do use substitution if you want, but because the derivative of h minus 20 is 1, think about like du and du, I don't have to do anything special with the u and the du since the derivative is 1. So I know the antiderivative of that is just ln of h minus 20. And then the antiderivative of negative 10 dt is negative 10t, and then don't forget your c. Alright, we want to rewrite it. Understood e there, so we have h minus 20 equals e to that power. Don't forget, I see that power, so that really means that I'm going to have h minus 20 equals b e to the negative 10. Add your 20. So here's our equation. But then we're going to plug in the 0 and the 30. 30 for H, 0 for T, subtract 20. E to the 0 is 1, so that's just B, which means H is 10, E to the negative 10 plus 20. Okay. This one's kind of strange because it still has P's and T's, but there's not really a way to get them together without factoring. So the first thing I'm going to do is I'm going to factor. I really want my P's separate from my T's. So I'm just going to factor out a P, and I'm going to leave the 2's with the T's because it's easier to solve that way. If you cross multiply, you end up with that. You divide by your P. Then you take the antiderivative. Okay, the antiderivative of dP over P is ln of P. Antiderivative of 2 minus 2t will be 2t minus t squared plus c. Alright, rewrite your question. ln of P equals e to that power. But I remember that I'm going to put a b in front. Then I'm going to plug in the 2 and the 6. All of that's 0 in the power, so b is 6. So your equation is P equals 6 e to the 2t minus t squared. Almost finished. Alright, this one's nice because it already has the dy's together and the dx's together. So I'm just going to take the antiderivative on both sides. The antiderivative of 1 over y squared, so that would be y to the negative 2. If I add 1, I get negative y to the negative 1. And then over here I get 3x squared over 2 plus c. Now I'm trying to solve for y, so what I would suggest here is to rewrite it as negative 1 over y. And because I'm going to try to cross multiply since I have a fraction over there, I'm going to put all of that over 1. And so when I do that, I have y times all of that stuff equals negative 1. And then you can divide. And then that's the answer. Now, this problem didn't give me like a y and an x so that I could solve for the original equation. And since they didn't give me that, then I just leave C in my answer and then I'm done. I just wanted to talk to you a little bit about actually solving because sometimes that's kind of difficult. Alright, last problem. I want to take the antiderivative on both sides. My y's and my x's are already combined. We did this one in class the other day, the 1 over e to the y, but it's kind of strange. What I would do first is rewrite it as y e to the negative y. Now I know the antiderivative of 5 dx is 5x. The antiderivative of e to the negative y. I have to use u substitution. And if you kind of do it in your head, that's okay, or you can write it out. If u is negative 1, du is, or negative y, du is negative 1, so there has to be a negative in there. And then so that would be e to the u, so the antiderivative would be negative e to the negative y. So let's solve for y. First thing I'm going to do is I'm going to divide both sides by -1. To get the y to come down, I'm going to take the natural log on both sides, because the natural log brings the negative y in front. And then I'm going to divide both sides by a -1. ln of e is 1, so I don't have to use that. So I have y equals negative ln of -5x minus c. Again, this problem didn't give me an original x and a y, so I don't have to solve for c. Alright, here's 2 more problems I want you to try. So this one, there won't be there'll be a c in the answer since I didn't give you an x and a y. In the last one, there won't be a c. You'll be able to solve for the extra c.